Okay, folks, so here we go. Real quick, I want to go through a few of these things here just to kind of review. All right, so number 7, we're asked to prove that the quadrilateral whose vertices are these 4 points is a parallelogram. So let's go ahead and plot these points real quick here. All right, so A has coordinates -1, 1. So this is kind of hard to see. I would suggest maybe like drawing in the axes because it's maybe they don't really stand out that much. So connect the arrows there, kind of help you get those axes in. And then we'll plot the point. So A has coordinates -1, 1. Okay. B has coordinates negative, just graphing points all the time. Hmm?
Why do we have to learn that?
1, 2, 3, 4, 5.
Because we can go measure.
Yes.
Go measure.
Working at McDonald's, we can measure the wall.
I was asking for a legitimate answer.
Right. I understand.
You don't really use geometry.
I mean, so yeah, if you want the real answer is because other people have decided that that's what is important for you to learn. And
You don't even use it unless it becomes like a math semester.
well, I would say geometry is used in things like construction as well. So, but like so specifically like this kind of skill, this exact thing, no. I'm sure you're not gonna be like traveling. You're not gonna be walking along the street sometime. Someone's gonna ask you, hey, I got these 4 coordinates here. Can you tell me whether it's a parallelogram or not? It's gonna happen. But for now, that's right. Yes, guys, there's way too much talking going on. Thank you. But for now, Jason, okay, this is where we are. This is what we're gonna do. We just gotta do it, okay? So, all right. Anyway, let's connect these dots here. Draw this shape. Okay. So there it is. A, B, C, D. All right. So does it look like it's a parallelogram? Yeah, it does, okay? Unfortunately, though, right, that's not good enough, but that at least gives us the confidence to say, okay, we probably plotted these points correctly, we probably do have a parallelogram here, it's just a matter of then showing that, okay? Well, again, what makes a parallelogram a parallelogram? Opposite slopes, opposite sides will have the same slopes, or opposite slopes will be equal. So all we got to do here is just figure out the slopes. So I'm going to say the slope of AB, right, we got to count the slopes then. So from A to B, I have to go up 1, 2, 3, and left 2. So that's going to be a slope of 3 over -2. Okay? And that should match up with what other slope? CD, right. Okay, so let's count that one. So from D to C, I'm going to go up 1, 2, 3, and left 2.
Oh wait, can you do that again? Because I got that wrong.
So from A to B, from A to B.
From C to D, like where are you counting first?
Oh, I'm sorry. You're right. I counted from C to D, and I accidentally.
Okay.
Okay. Sorry. So let me redo that. Yes. If I said from C to D, so I'm going to go down 1, 2, 3. That's a rise of -3 over a run of 2. Now, then thank you, Kay, because this is actually going to be a good point to kind of make here. Do A, B, and C, D have the same slope?
No, but yes.
So they do have the same slope. And you might say, but Mr. Whitmire, in AB it's +3 over -2, and in CD it's -3 over +2.
It doesn't matter.
Right. They're both going to end up being negative. Let me show it to you using a calculator, maybe kind of prove it to you here. If I take 3 and divide by -2, I get -1.5. If I do -3 divided by +2, I still get -1.5. Since their decimals are the same, that means their fractions are the same as well. Yeah, they both have one negative. So, okay, let's do the slope of BC. Okay, so the slope of BC, we're going to rise 1 and run 4, so 1 over 4. And then the slope of, let's do the slope of DA, because I'm going to do this in a different way as well. So I did BC from here to here, I'm going to do D to A. That's fine, yep. So from D to A, I have to go down 1 and then left 4.
Are you just trying to like...
Right, just to kind of show. No, well, no, not, hopefully not confused, but just to kind of like...
You're messing us up.
You're right, exactly. Here, this will really throw you off. That's my job. I want to just confuse you. Okay, so... Right, so the key here to remember, folks, is that they may not look equal, but Skylar's exactly right. If we divide a negative by a negative, it really simplifies to a positive 1/4. So it really is the same slope. And so that means we can say with confidence that AB is parallel to CD, okay, and BC, okay, is parallel to DA or AD, whatever you want to say there.
Shouldn't you do CB and DA if you're doing it that way?
It won't matter because we're just talking about slopes, so it doesn't matter, okay, because their slopes are equal, okay, so ABCD is a parallelogram because opposite sides, and you can abbreviate if you want to, are parallel.
I wish I knew it was 60.
Okay? Well, good. Parallelograms are pretty easy, right? Parallelograms are pretty easy. We'll get to the next shapes here. Rectangle's not too bad either. Rhombus isn't too bad, and square isn't really too bad, but
What's the hardest one?
the hardest one, I don't know, maybe like rhombus or square, just because we haven't really seen a lot of those yet. I mean, we've seen them, you know, but not in the context of a coordinate. That's all. Okay? So there's that. Questions on any of that? All right, so I'm going to leave number 8 there for you to be able to, you know, try one on your own. Let's flip over to then number 9. Okay? Now this next one, this next one is a rectangle. What did you say? Outsides are parallel. Okay. So let's do number 9. Again, I suggest you draw on your axes because it just didn't seem to copy. Derek? Is there an echo in here, Derek? That's pretty clever, Derek. I'll give you points, Derek. Can you go back to your seat, though, Derek, please?
Yeah, I got it.
Thank you. You can sit there if you ever are my student aide, but I'd have to accept you, and I don't know. Would you get work done if I had you as an aide? 2, 1, 2, 3. Okay.
Students know how to count backwards from 23.
That is an important skill.
This is not look right.
C and then D, -1.
Why are you plotting? Oh, I'm not plotting the right thing.
Yeah, we're on number 9. We're on number 9. That's okay. If you did one of the other top ones, we'll be doing those later too, so you didn't waste your time.
That's not the right.
Okay?
Can you hold on 1 second?
Yep. Okay, so wow. They were really nice to us in this one. The rectangle is not like, you know, turned at all. It's nice and just very straight. So we can actually use, we have a couple of strategies we could use here potentially, but we'll still stick with the slopes and things, okay, if we want to. Okay.
I don't know why I'm having a hard time grasping. It's like, I think I'm counting the wrong way.
Okay.
Are you actually 9?
Yeah.
Okay, yeah. So again, your x coordinate is 2 to the right, and then y coordinate's 3, so up 3. B has a coordinate 10, 3, so 10 right, up 3. C has coordinate 10, -1, so 10 right, down 1, and then D has coordinate 2, -1, so 2 right, down 1. Yeah, it's very important, obviously, we plot the points accurately, because otherwise we're going to be in big trouble. Yeah.
So like, as you did like here, would you do it like there?
Basically.
Like,
Mm-hmm.
Yeah, so I was wondering, how would you like do that, like slope AB is like equal to, and then would you just like count right across?
Yeah, basically. So let me show you the slope here. So the slope for AB, okay, so the slope of AB here, what's the rise from A to B? So nothing. What number would that be? 0. And then the run is, I think, 8. Okay? And then the slope for DC, same thing, right? Slope for DC is 0 over 8. So again, there's that. So obviously AB and DC are parallel. Okay, let's look at the slope of AD. Okay. So from A to D, we are running down 1, 2, 3, 4. So -4, but we're rising -4. We are running 0. We're not going left or right. and then the slope of BC is the same thing. We're going down 4 and over 0 like that. Okay, question?
Yeah, what if like the slope you see you kind of like CB?
If you went this direction instead,
Yeah, what would you?
it would be positive 4 over 0. I see what you're saying. Yeah.
Yeah.
Yeah. So,
You still get it wrong if you move it that way?
No, I would not. No, absolutely not. Because the key, things get a little bit funky when you deal with horizontal and vertical lines. I mean, hopefully, very clearly here we can see that AB is perpendicular to BC, right? I mean, that's very clear, right? And so, in this case, our argument is going to be not exactly right unless you count it kind of the way I did here, where, in this case, these slopes are opposite reciprocals. Now, you might say to me, but Mr. Widmeyer, 0 over 8 is not the same as negative 4 over 0, right? I mean, like, even if you flip it, it would be 8 over 0, not negative 4 over 0. But the key here is that this is 0, and this is something over 0, and that is then okay to show that these two things are perpendicular. So we're going to say that AB is parallel to CD, and AD is parallel to BC, and we know that because they have the same slope numbers. Okay, right, parallel lines have the same slope. Sorry there, Ramel.
What's under slope AB? What is that? 0, 8, 0.
0 over 8. Yeah. Yeah.
But like, I never understand which way I'm supposed to count it, because
It shouldn't matter either way.
especially with the ones that aren't like on straight lines. 'Cause,
Right.
I mean, it's obvious right there that you can like
Say it's perpendicular.
Up or down.
It shouldn't matter which direction you go, from one to the other or the other to the one. It should not matter. You'll still end up with one being negative, one being positive, so on and so forth. So they have the same slope, but we have to show one more thing, and then I'm just going to say that AD is perpendicular to AB. Okay? And so, ABCD is a rectangle.
So how did you tell if AD and AB were perpendicular?
Basically because, well, it shows it in the picture, and I know you're like, Mr. Whitmire, you just said we cannot use just the picture. The slopes here are basically opposite reciprocals. One of the slopes is 0, right? 0 over 8 is really just equal to 0. And then this slope's undefined. Negative 4 divided by 0, that's undefined, and so those are opposite reciprocal slopes.
Yeah, but how do you do it? Because I put that in my calculator, and 0 divided
Right.
by 8 is 0, and
Right, undefined, right, exactly. Your calculator can't find that value, but it is true, they are perpendicular, okay? Oh, sorry.
So you have to have 3 examples of like why it's a rectangle?
So in this case, we did this to show it's a parallelogram, right? Showing the opposite sides are parallel, and then just showing one right angle, now it's a rectangle. Boom, you're done. Okay, one right angle, because here's the thing, right? If I did AD is perpendicular to AB, so if I said AD is perpendicular to AB, that means angle A is a right angle. But if angle A is a right angle and this shape's a parallelogram, that means C has to be too.
Yeah, but I was just asking, would you like have to have like 3 examples like that, basically?
Yeah, this is enough right here, you're done. Yeah, well, basically, this is like a proof, basically, exactly right. You've shown now.
So is this going to be on the test?
That's sufficient. You will need to be able to explain whether a shape is a rectangle or not. Okay?
but you could technically say BC is perpendicular to CD.
Yeah, exactly, and it'd be the same thing. Yep. All right, let's scoot on here to number 11 now, okay? And we want to find that this shape is a rhombus. Okay? So, Q has coordinates, and again, draw in your axes there. Because I want to leave some for you to try as well, potentially, if you want to. All right. So, Q has coordinates 6, 7, so 1, 2, 3, 4, 5, 6, and then 1, 2.
Wait, for the last one you said, what, did you put A? Is this our review?
This is some of the review, yes. Mm-hmm. Yep. Okay.
How do we supposed to graph R?
So R, ooh, you're right. Man, that's annoying. 11. So we'll just have to kind of eyeball that.
Can you just pretend it's 10?
No, we can't, unfortunately, just pretend it's 10 because that will make, I know, you just basically just go over, eyeball it, if you would, please, because, yeah.
How in the world is that supposed to work?
S, and then T is 3, 3. Okay.
Do you actually like geometry?
Yes, I love geometry.
Do you like algebra?
Algebra's okay. I'm not a big fan of algebra.
Algebra's easy.
Okay. Okay, so, rhombus. Alright, to prove it's a rhombus, we first got to show it's a parallelogram. So we're going to count our slopes. So we'll do the slope of QR, the slope of TS.
So you're still finding slopes?
Yep.
That's what you do for everything?
Yep. In all these shapes, we first want to make sure that it's a parallelogram, and then we get into more specifics. Okay. What's the matter, Kyle?
We're on the wrong one.
Okay, yeah, we're number 11. We're number 11. Okay. So QR's slope, you can see it's going to be 0. I'm not even going to bother, count it. It's flat, so it's 0. TS's slope is always going to be 0. Again, it's just a flat horizontal slope, so it's got to have a slope of 0. QT is going to go up 4, right 3, so 4 over 3.
Wait a minute, wouldn't it be 0 over 5?
Yeah, but it's the same thing as 0. 0 divided by 5 is just 0.
So what do you mean, what, negative 30? Is it going left?
So you can put 0, over 5, okay, but that's fine, but 0 is also the
I
same.
like you say negative 3 plus is going left.
I'm sorry, I count from T to Q. So yeah, if you did Q to T, it would be negative 4 over negative 3, which is still then going to be positive 4/3.
Wait, why did you get 0?
Because QR, there's no rise. It's 0, right? So it's a 0 on top over 5.
I have a question. So if I, if I wrote 4 negative 3 for QT and
Yep.
RS 4 over positive, would you still count that as the same?
If you did Q to T, that would be like a negative 4 over negative 3, which would then, yes, that would be still the same, because what is a negative divided by negative? It still is positive. They'd still be the same thing. So yes, all right. Yes. Yep.
So I did QR and TS and TQ and RS. Is that
Okay.
okay?
Yeah, in a different order than I did it here. Yeah, that's fine.
For RS, I got negative 4 over 3. And for TQ, I got 4 over 2.
You miscounted then, okay. And also, so if you said RS, you got negative 4 over positive 3?
How do I miscount from 4 to 2 to 0?
Wow, that's a good question. I don't know, but it must have, because the slopes here are 4/3, I promise
Can
you.
you find that out? Because if I compare TQ to RS,
Yeah,
I can do that.
yeah.
Okay, so you go up 4.
From T to Q,
Yeah.
up 4,
And over 2.
right 3.
3, okay.
Okay, so QRST is a parallelogram. Okay, because opposite sides are parallel. Ramel, if you'd like, you can come over here and sit in Taylor's seat. There's an open seat there. That way you can see better, okay? Okay. So QRST is a parallelogram because opposite sides are parallel. And then for a rhombus, now this is interesting. A rhombus, we're not going to say the sides are perpendicular, but what are perpendicular in a rhombus? The diagonals. So let's find the slope of QS. Okay, so the slope of QS, so let's find that diagonal. Okay, so from Q to S, what's that slope? Well, if I go from Q to S, I'm going to go down 4, right 2. That's negative 4 over 2, which simplifies to negative 2 over 1. Okay? And then we have to find the slope of the other diagonal. What's the other diagonal? RT or TR, either one. Okay? So let's find that diagonal slope. Okay, so to get from T to R, I have to go up 4 and then right 8.
Yeah.
Yep, okay. So up 4, right 8. That's my rise over my run, which simplifies to positive 1/2.
So they are parallel or whatever.
Perpendicular, yeah. They are perpendicular. QS is perpendicular to TR. Okay. So QRST is a rhombus because the diagonals are perpendicular. Okay, this is why knowing those properties are so important, okay? They help us. That's a lot of writing there, I understand, but that's it.
Like in English.
I know, right? It's crazy.
English is like so much better.
My question is the same, but if someone uses ST,
So from S to T,
that would be,
okay, I see you're saying it'd be negative, but then it would be 0 divided by negative 5, it would still be a value of 0. So it should be okay still, okay? All right, last one. We're going to, oh, sorry.
Here.
We're going to skip to number 13, lucky number 13. Okay, and we're going to show that this shape is a square, okay?
So we have examples.
Yeah, exactly, so you have examples.
Wait, are you gonna give us more of these for homework?
I mean, it won't be for homework, but there are, like, basically, we skipped every other one, so the other ones you can try if you want some more practice. So for, like, you know, for review, the homework would be to study. I mean, so I would suggest you try some of these if you feel like you have difficulty with them, or I'll give you another review paper too, and you look over those problems.
They're coming in the class.
Yeah, absolutely, absolutely. I'll still call you for flex. Yes, yes, yes. Okay, so let's talk these points. A has coordinates 4, 1, 4, 1. B has coordinates 1, 5. Well, I want to make sure that we can get in our I want you to try it on your own too. All right, there's D. Okay. And we want to prove that this quadrilateral is a square. Okay? And basically, if you understood the last three, then this one is no problem. Okay? If you understood the last three, then this one should be no problem. Okay? The way it looks wrong? Oh, okay. It's actually, it's just, if you understood the last three, it's basically using all three of those and this one. Okay? So first of all, let's look at it. Does it look like a square? Yeah, if I turn my paper there, it's like, yeah, that looks pretty much a square there. Well, you know, because it's on its side like that, it's maybe hard to see. So you orient it more to myself. Yep.
So would you do like DA and
We want to find out all the slopes again. So find all the slopes. So slope of AB, slope of DC. We want to find, yeah, or CD. That's fine, Jason. That's fine. Slope of BC and slope of DA. Okay. So first thing we're going to do is establish that it's a parallelogram, right? So that means we have to just show that opposite sides are what? Well, congruent, but in this case, this is parallel, so the same slope. So we want to just show that opposite sides are the same slope first. So we'll just start counting our slopes here. So from A to B, I have to go up 1, 2, 3, 4, and left 3. So 4. Okay, 4 over negative 3 for AB. All right, DC. So from D to C, I'm going to go up 4 and over 3. Sorry, AKB, so you did it differently. How did you do it differently?
I did DA, CD, CB, DA.
Okay, that's fine. It should. So you had negative 4 over positive 3 and negative 4 over positive 3 then. Yeah, that's fine.
3 over negative 4 and negative 3 over 4.
Okay, and again, they'll be the same thing, right? Because 4 divided by negative 3 is the same thing as negative 4 divided by 3. Still gives you negative 1.333. All right, BC. We're going to go up 3. Actually, I'm doing CB because I get positive stuff. So 3 over 4. And then DA also has slope of 3, 4. Okay, again, if you counted BC or DA and got negative 3 over negative 4, that simplifies to positive 3/4. Derek, come on, man.
So would that one be right? For the bottom half?
DC, you should have gotten negative 4 on the denominator as well. Or wait, sorry.
No, because I did hear mine the other way.
Okay, sorry. Let me see your slope here. For BC, you should have negative 4 over negative 3, the way you counted. From B to C, because you went left 4, sorry, down 3 and then left 4 from B to C. So it should be negative 3 over negative 4 from B to C. Down 3, left 4. So negative 3 over negative 4 for your BC, the way you were counting. And then DA, Again, down 1, 2, 3, left 1, 2, 3, 4. So yeah, count your slopes there again.
So it'd be negative 3 over negative 4?
Which is the same thing as positive 3 over positive 4. All right, so with these slopes, is this shape a parallelogram?
Yeah.
Is BC parallel to AD? Yeah, they have the same slopes. Okay, so BC is parallel to AD, and is AB parallel to DC? Yes. Okay, so that means it's a parallelogram.
We're like speed measuring. Like, you didn't even put your segment sign, you're going so fast.
Yeah, you're right, I missed that one. There we go. What's the trouble, Jade?
I don't know why I can never stop this point.
All right, so just, I would say be very careful, make sure you count accurately, right? Yeah. Okay, so we're okay with this, though? BC is parallel to AD, AB is parallel to DC. Okay? Now, that makes it a parallelogram. How can we show that it's a rectangle? We have to see if the slopes are opposite reciprocals. Are the slopes opposite reciprocals?
Yes.
Yes. So AB, we can say, for example, is perpendicular to AD. Their slopes are opposite reciprocals, so therefore it is a rectangle. If you have a parallelogram with one right angle, it's a rectangle. And then how can we check to see if it's a rhombus? We need to look at the diagonals, right? And the diagonals need to be what?
So for,
Perpendicular, that's right.
yeah, for you to know the rhombus, you have to do the diagonals?
Yep, you got to do the slope of the diagonals. That's one more step you got to do. So the slope of BD and, equals, and so I'll just count that here.
So the diagonals have to be equal for a square.
He's not here. I don't know if you need to take a pass back, but he's not present. Thank you. Sorry?
So the diagonals for a rhombus and a square have to be equal.
They need to be perpendicular. Perpendicular.
Which means they need to be opposite.
Opposite reciprocals, right? So yeah, let's count it here from B to D. So up 1, 2, I'm doing from D to B. Up 1, 2, 3, 4, 5, 6, 7 over 1.
Isn't it negative 7?
Negative 7 over negative 1 if you did it the other direction, yes. And then the slope of CA. From C to A, I go down 1 and then right 1, 2, 3, 4, 5, 6, 7. So negative 1 over 7, voila. Are they perpendicular? Yes. So BD is perpendicular to CA. So that means it's a rhombus. And if you have a quadrilateral that is a parallelogram, a rectangle, and a rhombus, it must be a square. Okay?
Oh my God.
So there it is. It's a square.
Usually always square.
Sorry?
They usually always square.
If you have something that's a rectangle and a rhombus, in this case it is, then it will always be a square.
It technically could be a rhombus.
No, it is a rhombus, for sure. Right? A square is a rhombus. A square is a rectangle. A square is a parallelogram.
Is square always a rhombus?
Square is always a rhombus. Because what makes a rhombus a rhombus? It's a parallelogram with all four sides congruent. I guess it's a quadrilateral with all four congruent sides. A square has all sides congruent too.
And the
So.
diagonals have to be perpendicular.
Yep,
No?
and that's going to be true for a square too.
Wait, so a rhombus has perpendicular diagonals.
Correct.
And how to find that is you have to have opposite reciprocals.
Yes, of the slopes. Yep. Okay, so I'm going to pass out one more paper here for the review, okay? So here's the thing, guys, this is not homework. You can do as much or as little of this as you want. However, if you want to prepare for the test, I would really recommend you do this, okay? We'll take some time tomorrow to go over this, and also in Flex too, for those of you that are still, don't want to come in. What's that? That's right, yeah. Thanks. No, I wouldn't want that job. That's too crazy. That's too much crazy. I feel like I'd lose my soul if I did that. Anyway, so here's the paper. You don't have to do all of these. In fact, keep it out. I'm going to tell you which ones you can ignore. Okay, I'm going to tell you which ones you can ignore. Well, you can if you choose to. You can take one and pass it out.
Can we ignore this class?
You can, but then you'll be ignoring it again next semester.
It's true.
Yeah, I'll get you. What?
Oh my God, I
All right, 1 second. Let me just get this. Oh, you know what, too?
No.
All right, real quick, folks.